right, for this last video, you're just going to be reviewing for your final exam for Physical Science B. All right, so on your final exam, you need to understand scientific writing and just the different factors that you can use to improve the validity of scientific writing. You need to be able to use sources that are peer-reviewed to disclose all facts even if they do not support your hypothesis, and you also have to show evidence of scientific thinking in your writing. Along with that goes the ethics, and remember, ethical guidelines are needed for the way that scientific information is communicated because government funding has the potential to create bias, and so people might falsify their research so they can continue to get government grants. Businesses can fund research that can also create bias, and then poor research that can affect the health and welfare of the public. So sometimes people will come out with studies and they won't be scientifically backed up. All right, another concept that you learned about in Unit 1 was scientific reasoning, and you learned that there are two types. There are inductive and deductive. Remember that inductive reasoning is one that makes broad generalizations from specific observations, and deductive is where it starts out really general and then it becomes very, very specific. So inductive is broad and general, and deductive is very specific. All right, so getting into Unit 1, you started to learn about motion, and one of the ways that we represent motion is by talking about speed and velocity. So remember that speed is found by taking the distance of an object and dividing it by the time, and velocity is also found that way, only the difference between speed and velocity is that velocity will always have a direction. So here's an example problem. A car starts 10 miles north of its reference point. It moves at a constant velocity over the next 5 seconds, reaching a point of 10 meters past its reference point. What is the average velocity? So remember that velocity would be displacement divided by time. And so since he started 10 miles north of the reference point and he ended up 10 miles south, his total displacement would be 10 plus 10. Which is 20, and then the time that it took him is 5 seconds. So the velocity would be 20 divided by 5, which is 4 meters per second, and then you would have to have a direction, which he ended up south of the reference point. We can represent speed and velocity by looking at what's known as a distance time graph. So we would have the position of the object on the left-hand side on that y-axis, and then the time of the object down on the x-axis. And so you can see that an object that is going a fast, steady speed would have a nice straight upward line, whereas an object that is slowing down is going to have more of a slopey negative curve. An object that is stationary will just have a straight line, and then an object that is returning back to its reference point is going to be going back to the 0 point on the x-axis. So what does this distance time graph tell us about the speed of object A and B? So we know that the speed of object A is going to be decreasing, right? Because A is going back towards its reference point, whereas B is moving farther away from its reference point. So we know that A is going to have a negative velocity, or its velocity is going to be closer to the reference point, whereas B is going to have a positive velocity. A is going to be moving faster, and at time 10s is when they're going to pass each other. All right, so acceleration is a change in speed, and we find it by taking a change in speed and dividing it by the change in time. So here's an example. Based on this table, what is an object's acceleration? So again, we take the speed of the velocities, or of the object. So the largest velocity is 36, the smallest is 20. The time is 4 minus 0. So basically it's 36 minus 20 over 4 minus 0, which is 16 divided by 4. And so we end up with 4 meters per second squared. A velocity time graph represents acceleration. So remember that the slope of a velocity time graph is the acceleration of the object. So you can see that it's accelerating slowly. So it's have a really nice positive slope here. And then as it increases it quickly, it's going to have more of a steep slope. Steady speed, again, is a line. Slowing down would be a negative slope. Stopping, again, just a straight line, and so on. Okay, so let's look at the following problem. What is happening at 2 seconds and at 5 seconds? So here at 2 seconds, we have the object increasing in speed and then it stops. So what does that tell us? That tells us that its velocity is increasing until then the velocity is going down. So at time 2s, the velocity decreases, and then at time 5s, it's passing the point of origin, right? So at 2s, again, it decelerates, and at 5 seconds, it changes direction because, see, it's going from across the origin point. All right, a specific type of force that you learned about in Unit 2 are gravitational forces. Remember that gravitational forces are based on the mass of the object, and so we find that by taking the mass of the object and then the gravity, which is 9.8 meters per second squared, the constant here on Earth. So an example problem, a 60-kilogram skydiver is falling at a terminal velocity of 50 meters per second. What is the gravitational force acting on the skydiver? So remember that the force is going to be equal to the mass times the acceleration. So since he weighs 60 kilograms, it's just 60 kilograms times 9.8 meters per second squared, which is the force due to gravity on Earth. And so we end up with 588 newtons. When we talk about forces, we talk about balanced versus unbalanced. So remember that in a balanced force, there is no movement because all the forces acting on the object are the same. Whereas in an unbalanced force, there is movement, and then the force is unbalanced on the direction of the movement. So we can always tell which force is bigger based on the direction of the movement. A ball is at rest on the table. Which of the following correctly models the forces on the ball? So it's at rest, so we know that the forces are going to be equal. So the forces pushing down would be gravity, and the force pushing back on the book would be the normal from the table. Pascal's principle is a principle that says that pressure applied to any part of a fluid will be distributed throughout the fluid. So remembering that this is an important concept when we talk about like hydraulics in a car, the reason why your toothpaste comes out of the tube, just remembering that if you put force on any type of a fluid, it's going to distribute that force equally throughout the fluid. Mechanical energy is made up of two types of energy. We look at the kinetic plus the potential is going to equal the total mechanical. So we can always tell what one is or the other is if we know what the other two are. So remembering that those two equal the total mechanical energy of a system. The equation that we use to find kinetic energy would be 1/2 mv squared. So remember, m is the mass of the object, v would be the velocity squared of the object. The equation used to find gravitational potential energy would be mass times gravity times height. Here's an example problem. In order for gravitational potential energy to be stored, how does an object have to be positioned? So knowing that it's equal to mass times gravity times height, we have to assume that it would have to have some type of height in order to have potential gravity or potential energy. A specific type of energy, thermal energy, which is heat energy, can be conducted in three ways. It can be conducted through convection, which is the movement of colder air currents to higher, and that circulation of the hot air rising and cool air sinking. Conduction, which is just by touching something, and then radiation would be from the electromagnetic energy coming off from an object. Remember that thermal energy is related to temperature, and it's a measure of how much energy the matter has, and so it's a measure of the average kinetic energy of the molecule. So thermal energy is directly related to kinetic energy. So the more kinetic energy some substance has, the more its molecules move, the more thermal energy it also has. In Unit 4, you were talking about waves. Just remembering that you learned about different types of waves. Transverse waves versus longitudinal waves. Remember that transverse waves move up and down in an S motion, and these ones are going to have a traditional wavelength, whereas a longitudinal wave is more like a compression wave, and so think of it more like a slinky in a lot of ways. The way that we find the speed of a wave is we use the wave equation, which is the speed of the wave is equal to the frequency times the wavelength of the wave. An example, a tuning fork vibrates at 200 hertz. If the sound travels at 1500 meters per second, what is the wavelength? Remember that wavelength is equal to speed divided by frequency, so we take the speed. 1500 divided by the frequency 200, and we end up with 7.5 meters. All right, in Unit 5, you started learning about optics. And one of the things that you went through was you were talking about mirrors. So just remembering that a plane mirror is basically the type of mirror that we look through. And it consists of a two-dimensional surface that reflects the light coming off from another object. And so when these rays strike this mirror, the angle of reflection is equal to the angle of incident. And so the object will appear to be behind the mirror surface at an identical distance away. And so this is really kind of how the mirrors that we use works. There are two other types of mirrors that you talk about in Unit 5, concave and convex. Remember that these are mirrors that form virtual images. And remember that concave are curved outward and convex are curved inward. So concave is converging, convex is diverging. Concave mirrors can also form real images depending on their distance from the object. All right, and then in Unit 5 you also talked about electric fields. So remembering that things that are electric, that have electricity flowing through them are going to produce an electric field. And so things that are closest to the source are going to experience that field much greater than those that are farther away. Electromagnetic waves are formed when electromagnetic fields couple with magnetic fields, and the magnetic and electric fields are perpendicular to each other, and so they're going to differ in wave and frequency. So here's just kind of a picture of the electromagnetic spectrum, remembering that these differ by frequency and wavelength. So those with the tiniest wavelength will be the most dangerous, like gamma rays, X-rays, and those with the largest wavelengths, like radio waves and microwaves, will be less dangerous. Which band in the electromagnetic spectrum has the longest wavelength? And we just looked at that. That was radio waves. What type of wave cannot be seen by human beings? And so we can see that basically there's only this type of wave that can be seen. It's the visible spectrum. And so the one that would create different parts to the body would be the X-ray. And then you learned about Ohm's law, which says that voltage is equal to current times resistance. And so remembering that voltage is in volts, and it's the potential that drops across the resistor. There's current, which is equal to I, which is in amps, and then resistance, which is found in ohms. So here's an example Ohm's law problem. If a current of 2 amps is moving through a circuit connected to a 9-volt battery, what is the resistance of the circuit? So we know that amps is current and V is volts, so we know that we're solving for resistance. So resistance is equal to voltage divided by current. So it's 9 divided by 2, which is 4.5 ohms. All right, well that is it for the review for your final. If you have any questions, please let me know. Go ahead and use this video to fill out the Unit 6 video assignment questions. Thanks.